problem, we're given three algebraic expressions and we are to write them in factored form. The first of which I notice has a greatest common factor to both of the two terms. So to pull out the greatest common factor, I noticed that I could factor out a 4 out of 12 and 4, and I could also factor out an x. So you can think of this technique as the reverse of using the distributive property. So imagine someone that is going to distribute this to two terms here. Your job would be to find what do you put right here so that when someone multiplies 4x by that, they get 12x squared. So that's the idea. So the first thing I'm going to notice is that I could multiply 4 times 3 to get 12. And then x would have to be multiplied by x to get an x squared. Then the next question after somebody was to distribute that would be what do you multiply 4x by to generate this term? But you're trying to generate a 4x and we have a 4x. You'd simply multiply by the number 1. And I've successfully factored out a 4x. So this is called the greatest common factoring technique. Down here, the trinomials with leading coefficient 1 are pretty simple to factor. So it just turns out that factoring this is like the reverse of foiling. So like up here, it was sort of like undoing the distributive property. You could think of this as undoing the FOIL process. So I need to put something here and here so that when someone were to start the foiling process, they would get x squared. So commonly we put an x here and an x here. Now, there's actually 4 multiplications that happens, right? That's just the first one. Typically, the order would be to multiply this, and then whatever you put here times this. And then the last multiplication is usually done by taking what you put here and multiplying by that number. And this number times that number would generate the negative 5. So it's our job to write down the different possibilities of the numbers we could put here so that when someone multiplied them, they'd get negative 5. Well, the fact that the 5 is negative means that when I multiply these two numbers, that one of them will have to be positive, one will have to be negative. That's the only way to multiply two numbers and get a negative out. So one possibility would be 1 times negative 5 gives you negative 5. And the only other thing I can think of is negative 1 times positive 5 would work. So either way would generate negative 5. So the question is, which do we do? Do we put a plus 1 here and a minus 5 here? Or should we put a minus 1 in the parentheses and a positive 5 here? So it's actually, I've heard this called the trial and error method because it is a little bit of trial and error. So I'm just going to pick a way unless you can see ahead of time what it's going to be. If you have some practice, you know because you're trying to generate a positive 4, that you're going to want a positive 5 and a minus 1. In fact, a lot of people would say that you need two numbers that multiply to give you negative 5, and those same two numbers have to add up to be 4. So if you wanted to go that route, you could say, well, which of these two pairs of numbers that I found that multiply to give negative 5 would also add up to be the middle term 4. So our possibilities were 1 and negative 5, and the other possibility was negative 1 and positive 5. And they satisfied this condition that they multiply to give negative 5, but only one of them is going to satisfy the condition that they added before, and that's the second one. 1 plus negative 5 is negative 4, so that one won't work. So put a little sad face there. The one down here, negative 1 plus 5, is 4. So you're basically finding the two numbers that multiply to give you negative 5 and add up to be 4. And after all this mess, we found out that the answer is negative 1 and positive 5. It is worth taking the time to check, and it wouldn't matter if you put the negative 1 here and the positive 5 here, or vice versa. Either way would work. So it is worth taking the time to check. So x times x would give me x squared. This times this would give me x times 5 is 5x. And that's not 4x, but the next multiplication would be negative 1 times x, which gives me negative 1x. And then when someone were to combine these two terms, they'd get 5x, subtract 1x, which is 4x. So that's going to work. The last thing to check would be when someone multiplies this times this, they indeed get negative 5. And they would. A negative 1 times a positive 5 is indeed a negative 5. So this is called the trial and error method. So you have greatest common factor, trial and error. This down here is called the difference of squares. A number is a perfect square. Any algebraic expression is a perfect square if it can be written as something squared. It's like fill in the blank. So for example, 36 is a perfect square because I can write it as 6 squared. The fact that 36 can be written as 6 squared means that 36 is a perfect square. Well, look at x squared. x squared can be written as x squared, right? So it itself is a perfect square. So it turns out if you have what's called the difference of squares, and that's the method of factoring here. So I just proved to you that these two things were perfect squares, but now I'm going to do the difference of squares, and in mathematics, the word difference means to subtract. It's just a known fact that if you have some number a being squared, and I shouldn't say some number, but some algebraic expression squared, and you have some other algebraic expression squared, and you are subtracting them, that it can be factored as a plus b and then multiplied by a minus b. It'll have the same look as this up here. So the idea is think of x squared like this, and think of 36 as 6 is being squared. And if you did that, then just comparing the two here, think of this as x squared minus 36. And if you compare, here the a would be x, and here b would be 6. So once you know that, once you identify what's being squared here is x, and what's being squared here is 6. In fact, if you let a be x and b be 6, then a squared minus b squared would literally become what? Instead of a squared, if I replace a with x, this would become x squared. And imagine me plugging in b equals 6. Instead of this being b squared, it would be 6 squared. So notice for this choice of a and this choice of b, plugging it into a squared minus b squared literally gives me x squared minus 36, which it should, otherwise I'm not doing the problem that I was asked. So this will factor as a plus b and a minus b. So my a was x and my b was 6. Let's see if I can make that look more like a 6 rather than a b. So it turns out that with this algebraic expression, it can be written as x plus 6 and x minus 6. I didn't leave a whole lot of room to check, but you could multiply this out and FOIL and see that you do indeed get what you started with. So let's check to see if I'm correct. I claim that it can be factored like this. So the check would be to actually go backwards now and FOIL it just like we checked this one up here. So you would get x times x is x squared. You'd get x times negative 6 is minus 6x. You'd get 6 times x, but it's a positive 6x this time. And then finally, you'd have 6 times negative 6, which is subtract 36. So we would keep this x squared, we would keep the negative 36, but one could combine the negative 6x here and the positive 6x. And if you added those together, you would get 0. In fact, if you wrote 0, you could argue that 0 subtract 36 is still just minus 36.